All right, law signs, law cosines, do some application problems here. So you've already got this sheet for your notes. I just want to go through examples 1 and 2 here, show you how they work, and then we will do some problems on this tomorrow. We're going to spend the next 2 days doing this. So example 1 here, this is a good one to start with. Boat in distress at sea, sighted from 2 Coast Guard observation points A and B. The angle at post A, and that's really what you need to focus on, is the angle at post A is 41.67, and the angle at post B is 36.17. And then it gives me the distance from post A to post B is 24 kilometers, and I want to find the distance from post A to the boat. So the first thing we need to do is to draw a picture here. So I'm just going to put post A down here and post B over here. And I know that the distance between those two is 24 kilometers. Okay? And then somewhere out in the ocean, we've got, a boat out here. And so we can see the boat from point A and point B. And it doesn't have to be a perfect diagram, just as long as we get a picture of what's going on. And it tells us that the angle at post A is 41.67, and the angle at post B is 36.17. So that's what we know right now. And then the question says, find the distance from post A to the boat. So what I'm going to do is, I've got AB, I'm going to label the boat here as C, and then I know that this is lowercase a, that's lowercase c, sorry about that, lowercase c, and this side is lowercase b. So when the question says find the distance from post A to the boat, what I'm really wanting to find is lowercase b, based on my diagram that I have here. That's the information I need. Okay? So if we were to write this up like the problems you've been doing, like what you've seen here, we know that A is 41.67. We know that B is 36.17. Capital C we can find just by subtracting those from 180. Lowercase a we don't know. Lowercase b is what we want to find, and we know that lowercase c is 24. So what I'm going to do is I'm going to go ahead and find capital C here by simply taking 180 minus 41.67 minus 36.17. So I'm just going to go ahead and work that out. And that gives me 102.16. And that's going to be my capital C. So now what I want to solve for is B. That's what we're looking for, because that is the distance from post A to the boat. So when I look at this problem now, I notice that I've got a capital C and a lowercase c, which means I have something in common. So this is a law of signs problem. So when I do this problem, I don't even need to worry about A. I'm just going to find out what B is. Okay? So I'm going to go sine of 102.16 over 24 equals sine of 36.17 over lowercase b. And then we just cross multiply like we always have when solving. And be careful here, and I noticed this on some of your quizzes, you just divided by 102.16. Make sure you divide by the sine of 102.16. So when we do 24 sine 36.17 and we divide it by the sine of 102.16, we end up with 14.5, and that is kilometers. And that is my final answer, because that's what I'm looking for here. So the distance from A to the boat is 14.5 kilometers. Okay? All right, so let's look at example 2 here. It says that 2 ships leave a port at 8 a.m. One travels at a bearing of north 50 degrees west at 15 miles per hour, and the other one is a bearing of south 65 degrees west at 18 miles an hour. How far apart are they at noon that day? Well, in order to do this problem, I got to show you what bearings is. Okay, so let me show you just on this sheet what bearings means. So when you do a bearings problem, you have to draw your cardinal direction, so north, south, east, and west. And whenever you do a bearings problem, everything works off of the north-south line. So everything works off the vertical line. So in this problem, when I say that it is north 50 degrees west, what that means is I start on the north line, and then I'm going to rotate 50 degrees towards the west. So I'm starting here at the north. I'm going to rotate over 50 degrees towards the west. And what that does, everything starts from the origin. It gives me a direction that my ship is heading in. Okay? So now, if that's 50 degrees, then I know that this angle would be 40 degrees because those two angles have to add up to be 90. But when you do a bearings problem, you always go off the north-south line. So let's just say I wanted to go south 70 degrees east. So what I would do is I would start here on my south line, and I would swing 70 degrees all the way over towards the east. So that would be a 70-degree angle right there, which means that would be a 20-degree angle right there, because again, they have to add up to be 90. Okay? So in looking at example 2 here, two ships leave a port at 8 a.m. One travels north 50 degrees west, the other south 65 degrees west. And how far apart are they noon that day? So let's get a picture of what's going on here. So I'm going to do my bearings. So I'm just going to come right here. I'm going to draw my cardinal directions here. This is a little bit tough. It can get a little bit messy when you're doing these problems, but as long as you space it out good, you should be okay. All right, so let's do north 50 degrees west. So here's the north, south, east, and west. So north, I'm going to swing 50 degrees to the west. So I'm going somewhere about right in there, maybe. Okay? So that means that this angle here is 50 degrees. Started at the north, swung to the west, which means this angle in here is 40 degrees. Okay? And we know that that is traveling at 15 miles per hour. Okay? And again, we're starting at our origin here. All right, and then the other one is south 65 degrees west. So I'm starting south, and I'm going to swing 65 degrees to the west. So this one's going to swing a little bit more this direction here. And that's 65 degrees, which means if I do 90 minus 65, that means that this angle in here is 25 degrees. Okay? There was my 65 degrees, there's 25 degrees. Now the question says, how far apart are the two ships? So here to here is what I am looking for. Okay, and I'm just going to label that as X right now. All right? So we got a lot going on here. So what I'm going to do is this. I'm going to take my triangle that I now have, and I'm going to rewrite it over here. I'm going to redraw the picture that I have here, essentially. Okay, I've labeled this side as X. And what I know is this angle right here is one of my angles of my triangle. So if I take the 40 and the 25 and I add them up, that tells me that that angle is 65 degrees. Okay? Now, I do have some other information that I haven't put here. It says this one traveling north 50 degrees west, so that's this ship, it's going 15 miles per hour. Well, if it left at 8 o'clock and it traveled till noon, that means it traveled for 4 hours. And if it's going 15 miles per hour, then that means 15 times 4 hours would mean that I've traveled 60 miles. Okay? So if I did 15 miles per hour times 4 hours. And then here, this ship that went this direction, the southwest direction, is traveling 18 miles an hour. So if I do 18 miles an hour times 4 hours, again, it left at 8, it's now at noon, so 18 times 4 gives me 72 miles. So now I've got some more information in order to do this problem. Okay, now what I'm going to do is I'm going to set this up. I'm going to say, okay, there's A, there's B, there's C. So instead of this being X now, I'm going to label that as lowercase b. This is lowercase a, that's lowercase c. So here again, what I'm looking for in this problem is that information right there, lowercase b. So let me write this as you've been seeing all the problems. Okay, don't know capital A. Capital B is 65. Don't know capital C. We know lowercase a is 72. Don't know lowercase b. That's really what we're trying to find. And lowercase c is 60. So when you look at the information, you have lowercase a, capital B, lowercase c, which means all of the letters are different. So that is a law of cosines problem. All right. Now what I'm looking to solve for is this b. So I'm going to go b squared equals a squared plus c squared minus 2ac cosine of b. Now here's the nice thing. This is one of those that you can just type into your calculator. And when you do that, you end up with 5132.58, and then we square root, and we get b is 71.64 miles. And that is how far apart the ships are at noon. And that was what I was looking for. All right, we'll wait and do example 3 later, but that gives you a good idea about how these problems are going to work.